right? So these things we'll see in a today's session, and how to work with the GUI. Okay, now see when I'm using Hadoop from the Cloudera, when you start the cluster, by default Hadoop processes will started and running in the machine. And in I told you in the previous session, like, so we have the scripts like start hyphen dfs.sh, start hyphen mapreduce.sh, start hyphen yarn.sh, start hyphen all.sh. Generally these are the scripts which are used to start the Hadoop cluster. And the reverse, we have everything with the stop hyphen dfs, stop hyphen mapreduce, stop hyphen yarn, stop hyphen all dot sh. So these are the scripts which are used to stop the cluster, right? So here using the Hadoop means, see, half your Hadoop is configured. Hadoop is configured as a standalone mode, or Hadoop is configured as a pseudo distributed mode, or Hadoop is available in a multi-node cluster. Suppose if the Hadoop is available in a multi-node cluster, means you're having four data nodes, one name node something, or it's a pseudo distributed mode, everything configured in one machine, or it can be a standalone machine where we are going to test the jobs, right? Now starting the Hadoop in a standalone machine doesn't make any sense. We don't have an SDFS, right? We simply start a map reduce and will take the data from the local file system and it will process it. Forget about that. Now the actual thing comes here when we are working with a one node cluster, or when we are working with a multi-node cluster. Suppose if Hadoop is running in a one node cluster, then what we have to do, now first identify how the cluster is configured. If the cluster, the Hadoop in a cluster is from the Apache Hadoop, or is the cluster in, is the cluster is configured with Cloudera, or is the cluster is configured with MapR, right? Suppose if it is Hadoop from the Apache, then we use start hyphen dfs.sh and all these scripts. Can you yes, you have any question, Raju?
No, Ajay, no.
Right, Nageshwar and Santosh, can you able to hear my voice?
Yes, there's no problem there.
Right, fine. Okay, so if you're using Hadoop from the Apache, then we have to start these scripts. Yes, Nageshwar. Nageshwar, it's okay from my side. Check your headset. Here others can able to listen my voice. One node cluster. Now what we have to do, we have to start the Hadoop in one node. And if you are using Hadoop in a multi-node cluster and you are using Hadoop from the Apache, then you have to start the Hadoop in all the nodes. So how many nodes are there? Now we should able to run the script to run the Hadoop in a cluster, not on individual machine. Suppose if it is a 10 data nodes are available, means you should make the Hadoop available in all the 10 data nodes, right? So that is if you are this Hadoop from the Apache. Now if you are using Hadoop from the Cloudera, now when you start the Cloudera, so by default the Cloudera will have Cloudera manager. So if the Cloudera manager is running in your machine, then that thing that, so this Cloudera manager by default it will start and stop the Hadoop in your system. We know manually start and stop the Hadoop in a Cloudera, right? Either it can be a Cloudera manager if you are using, or if you are using a Hadoop from the Hortonworks, or if you are using Hadoop from the Mapr. If you are using Hadoop from the Cloudera manager, or if you are using Hadoop from the Hortonworks, Hortonworks will have Ambari by default is enabled, so Mapr is enabled by yes.
Vishnu,
Hello.
yeah, yeah.
Right, so the mapper is having mapper control system. Now so these are the three admin tools. It's a in the Cloudera, so it is a Cloudera manager. If it is an Hortonworks, then it is an Ambari. Then if it is a mapper, then it is a mapper control system. So these three are running in your cluster in your Hadoop. Means by default these scripts will start Hadoop in the cluster, so we manually we never try to start and stop. So by default, if Hadoop started by the Cloudera environment, if you have started the cluster with the Cloudera manager, then it's by default it will start the Hadoop even it's from the Cloudera or from the Ambari or the MCS. But particularly if you are using Hadoop from the Apache, then we have to manually start all the Hadoop daemons in the cluster. Right? See here, this is now if you open a browser. Now we can see here it's a Hue and the Cloudera manager. If you click on the Cloudera manager, now I'm logging into the Cloudera manager, right? So write your username Cloudera and the default password provided here is a Cloudera. Click the button login. Right, now see, so these are all the services by default they have started and running in the machine. SDFS, Hive, Hue, Impala, right? So MapReduce, Uzi, Scoop, PR, Zookeeper. So now these are all the processes which are started in the my cluster. You can see in the host section, see I have a host which is my name node is configured in a localhost dot local domain. Right, so if we click on this, we can see the name node of information about my cluster and the configured capacity for the cluster. Otherwise, now remember this web UI name node is available on 50070. These are the web UIs where we can able to see and connect to the name node and the data nodes and Hadoop daemons to see the statistics, to see the information about the Hadoop domains which are running in the cluster. So now if you want to see the how many data nodes are configured in the cluster, we don't know, right? So you have given an access to the cluster, so we don't know that how many name nodes are there. So the first, how many data nodes are there? One thing, we can use the Cloudera manager. So in the Cloudera manager, we can see the services. Now here, how many name nodes are there, how many data nodes are there is going to be listed. So the complete rack information is available. Otherwise, now connect to the name node and a port number, which web UI. It's a web user interface where we can able to see the statistics, where we can able to see the information through the browser, where we can see able to see the information about Hadoop daemons through the browser. Now, Hadoop is in the Hadoop, the name node is running on 50070. So right, so 00 it's an IP address and write 50070. Press enter. Right. So now this is where information about the name node which is running in my machine. Right. So this is the IP address of the name node because I have configured Hadoop in a one node cluster. So it is now it's a one node cluster. So and I have configured Hadoop daemons in one machine, which is a pseudo distributed mode installation, and I have configured it as a local host. So here I am using 0000, and the name node is running on the port number 8020. Right, so what is the difference here? 50070 is for the web UI, it's web UI port, right, where we can able to see the information about the name node, and 8020 is the port where the name node is configured. So this is the difference between 50070 and 8020. 8020 is the port number where name node is available, and 50070 is the web UI port number where we can able to see the information about the name node in a browser, right? So now, so here this is when the cluster started and what is the version of the Hadoop which I'm using in my machine. So if whenever if you perform any upgrades, and this is the cluster ID, so this we have to remember this cluster ID, and this is a cluster ID. So my cluster ID is a cluster 1 1, and so the black pool where the data node is writing its data is identified with a black pool ID. Means the files which we are writing into the data node, so they are written and referenced as a black pool file, and that black pool file will be given an ID, that is a black pool ID. We'll see this about in the chapter 3. Okay, right? So this is information about your cluster. Now if you see now how many nodes are there in your cluster, how many name nodes are there, how many data nodes are there. If you want to see the information about your cluster, now scroll down. Now you can see able to see here how many live nodes are there, how many date nodes are there. Live nodes are there, like, so now it will list all the date nodes which are connected to the cluster, which are up and running. They are live, right? Means they have connected to the cluster where we are going to store the data which are going to be distributed to all the data nodes which are available, and which status is showing that they are the live. So here the live nodes are the nodes which are up and running. So now here in my machine I have only one data node is configured, so there are the live data nodes are one. Okay, so where this data node 1 is configured in a local host. Suppose if you're in your office, if it's a cluster with the 4 data nodes, then you can see here live data nodes are 4. So now here it's a node 1 name, and in after that you'll get the node 2, after that live node 3, after that live node 4. Now if you click on the local host, now we can see the files and available in that particular data node. So how many data nodes are there? So if you click that one, it will list this one. Okay, so now where we can able to see the how much disk we have configured for this particular data node, and how much disk space you have utilized, how much space left, and how much percentage you have used in that particular disk, right? So is going to be displayed. So number of blocks, right, which is used in this one is 2346, right? So like this it will show you the complete statistics about the data nodes. Now it's a name node and the data nodes, and I told this one, right? So we can always connect to the data nodes through the name node. Without the name node we cannot navigate to the data nodes directly. Suppose if I want to see this local host local host. Now if you click here, so now we are navigating to 50075. So this 50075 is the port number which is dedicated for the data nodes, right? So name node is available in 50070. Then data nodes are available through web UI. We can connect to we can able to see with the port web UI port, that is 50075. But if you try to connect to 50075 directly, right? So we can't able to connect to. See here, if you write 50070, we can able to connect to the name node. But I told that 50075 for the data nodes. Now if you're trying to connect to through 50075, now we can't able to connect to. So to connect to the data nets, first you must connect to the name node. So connect to the name node, that is 50070 where your name node is running. Connect it, and after that, so now if you click the browse the file system, then we are connected to the that particular data node to see the files and folders in that data node. Okay, now see here, if you want to check this from the Cloudera manager, now click on the services, right? All services. Now see here in my cluster, name node means it's an comes to the SDFS domain, right? So where SDFS running, click here, right? See now in my machine, data node, name node, secondary name node, balancer, right? So these are up and running. Now you can see here name node web UI, right? So this particular option, name node web UI, where uh, we can able to connect it to the name node through web UI. See here, right? If you don't remember this port number, then you have to use web UI through the Cloudera manager, right? So just see now, when you see the status of the name node and good health, the data node is in a good health, secondary name node is in a good health. Now suppose you want to start the data node, or you want to stop the name node, you want to stop the secondary name node, both stop and stop we can able to do from here, right? Click on this button actions. Right now we can able to stop the SDFS, and we can able to start the SDFS. So when you start the SDFS, then it will start the data nodes, name node, secondary name balancer. So if you run individually with the command SDFS, now we have name node, data node.
So if the SD
Hello? Yes,
it is, yeah, Jay.
yes, Raju.
If HDFS get any problem like the name node will go down, so it will stop HDFS.
If your see, if your name node is goes down or your data nodes are goes down, our enter cluster is down. Suppose if your data node is goes down, nothing is going to be happen, right? Simply it will send a mail to the admin that so this particular data node is down, that's it. Apart from that, so it doesn't make any issue with in your job tracing. But your name node goes down because if the name node is single point of failure and we can't able to connect to the cluster, so immediately you need to troubleshoot the issue, how you can have configured the cluster. So you are using high availability, or you are using Hadoop with the Cloudera, or Hadoop with the Mapper, or Hadoop with the Hortonworks. So based on that one, so immediately it will take, if it is auto fencing is enabled, then another node, name node will be active and up and run the cluster. So we'll have the different types and the different times with the different scenarios are there.
Okay. So if we get any problem in like a base or anything, so it is stopped. If we get if it is get any error, so how can we resolve the issue?
Yes, that's again the thing where you have configured HBase. Suppose if we use HBase along with the zookeeper, or HBase without the zookeeper, again the two things. And HBase with zookeeper, the steps are different. HBase without the zookeeper, how we are configuring the it's a different. Both the things are there. Suppose if it is a, if you configure with the zookeeper, suppose if the HBase goes down, nothing is going to be happen, where we cannot only we cannot able to access the HBase, but the cluster is good and up and running, we can able to continue with your job processing, but only the HBase is not available, right? So if there is no zookeeper is configured and you have used HBase, in that case if the HBase is down, now, so which data nodes HBase is running? That's see one node or multi three nodes generally we use for the HBase. So based on that one, we have to idea we can able to troubleshoot the issue, right? So how you configure the HBase with the zookeeper, without a zookeeper?
Okay. In Mapper also same.
Yes, here it can be Hadoop from the mapper or Hadoop from the Cloudera, Hadoop from the Hortonworks. It's the same, but when it is coming to the mapper, it's a little bit different. So mapper is having its own file system, mapper file system, but not mapper relied on SDFS. If it is a mapper relied on SDFS, it will be the different, but they have their own file system, right? So Hadoop is using SDFS, Cloudera Manager is using SDFS, Hortonworks is using SDFS, except the Mapper. So they are not
Yes.
using the SDFS, they are using Mapper file system, right? So which is means if you want to work the Mapper, means Mapper file system is they are using Linux. That is, if you are working with the Mapper Hadoop, means you must know the Linux, Okay, so because Hadoop with the Cloudera manager, they are using SDFS, so which is no way related to the operating system level, right? So SDFS is its own, built upon its own, right? It's a SDFS file system. Now the Works also what they did, they are using SDFS, right? So we have to work with the SDFS. Now, so when in the mapr, so mapr is they are not using SDFS, they are using mapr file system, which is a native of the Linux file system. So both Linux and mapr file system are integrated together. So that is, if you are working the mapr, so we have to work with the Linux. But here in the Hadoop from the Cloudera manager, Hadoop from the Ambari, so we know from the Works, it's if you know the less Linux, even if you don't know the Linux, we can. But when it is coming to the admin part, you must know the Linux for to work with the mapper file system. Right, so you just go through the recommendation, the Cloudera versus Works versus Mapper. Just Google it. You can able to see the different distinguishes between the three distributions.
So if HBase is stopped, if it is get any error, so if you want to solve the issue, so we have to use in terminal, or we can do directly in GUI also.
Raju, please, this is not the session for the HBase. Please, we'll talk about the Hadoop daemons, how to start and how to stop. Okay, so we'll see the HBase
Okay.
things later because other also there they'll may get interrupted with the regular session. Okay.
Okay. Okay.
Yeah. Okay, now see, 50070 data node is 50075, right? Now we can see the data nodes is in good health, name node is in a good health, secondary name node is in a good health, right? So like this, we can able to see. Now suppose your cluster is started, SDF is started, mean everything is goes well, that is SDF is going good, and then map reduce is going good, that means the cluster is in a perfect health state, right? So when it is a map reduce, the task tracker is a good health, job tracker is in a good health. That is both SDFS and map reduce are well and working with the fine. So both are in a good health, right? So we can see the name node, it's 50070, and the job tracker, it's on 50030, and task tracker, how much it is? Nageshwar, 500.
535.
60. Okay.
Six.
Yeah, and secondary
Mm.
name node. Just try to remember Nageshwar these numbers. Santosh,
Okay, okay.
Santosh, right?
Yes, yes.
You should remember these port numbers, right? Uh, it's
Sure.
mandatory, right? You need to know these numbers. Okay. So task tracker is available in 50060. Secondary name node is in 50090. If you are running with a YAR, then it is 8088. Okay, so try to remember these port numbers. Now either it can be in your office, or if you're practicing at home. So now, so we have to connect, we can see this name node in 50070, and we can see the status of the jobs which are running. Suppose you have executed a MapReduce job and you want to see what are the jobs which are running in the cluster, right? How many jobs are completed, how many jobs are in pending, right? That you need to do. You need to check like what are the number of jobs which are running in the cluster. How we will check that one? We go through this command and we'll check, right? So this is a one interview question, right? So how you check what are the jobs are running in the cluster? The two things: one, we use the command Hadoop space job. One, this is a one command where we can able to list what are the jobs which are running in the cluster. Otherwise, we use 50030 web UI to see the jobs which are running in the cluster. Okay, Santosh, it's a question compulsory. Then maximum you'll get this question interview, right? How you check what are the jobs which are running in the cluster? Because our role is to run the jobs, right? So we are writing a program in Hive, you are writing a program in Pig or a map reduce, wherever you're writing. That means writing, it means you're writing the jobs. Now, how do you check what are the jobs are running in the cluster? How many jobs are running? How many jobs are successful? How many jobs are failed? What are the job configurations? What are the job log files? Right? All those things we can able to see through WebUI 50030, right? So you should tell that. So we have to connect through WebUI with the port number 50030, where we can able to see the information about the jobs which are running in a cluster. This is a one answer. Otherwise, from the terminal, run the command
Hadoop.
Hadoop space job hyphen list. This command is Hadoop space job hyphen list is a command which will list all the Hadoop jobs which are running in the cluster. If any job is running, the job is displayed with a job ID and job status, when the job is started, and what is the username, and what is the priority. If it is a schedule, information about the schedule when you have scheduled that. So these are going to be listed. Okay, so got it now. How to check the status of the job? Right, one is
Yes.
this one, and other one is the command Hadoop space job.
Mm.
Right, so try
Understood.
to remember. So this we have to do an everyday task. Okay, and it's a 50030 is the job tracker. And if you go to the 50060, then it is
Task.
task tracker, right? Where so the task is given to the task tracker. So task tracker will execute the job. Once the task is completed, task tracker will kill the uh, delete the files which used by the job tracker, and it will kill the damage processes which are running for the job, which are used to run the job. Right, once the job is completed, it will clear everything. Once job status is finished, so whatever the files related to, what are the temporary files related to, what are the process related to that job, so it's going to be killed, and the temporary files are going to be deleted. So we won't get anything in the task tracker. We can able to see
Uh,
whenever you run the job, immediately the job task attempts will be listed here. Once the job is completed, the output is given to the user. Now here everything is going to be deleted, so that we cannot able to see anything is here as of now. Yes, yes, Santosh.
Ajay, Venkat here. So here, suppose if there is any issue in between processing the job to the uh, user, and can we do the troubleshooting in this thing? Or because you said once it is processed, it will
Yes.
be deleted from.
No, we can't do anything with the task tracker. But suppose if the
Hmm.
job is failed, then we'll see the task attempt ID. How many attempts it will try to run the job. First, see, suppose it's available in data node 1, and it is running the job. Job is working well up to 60% job completed. And then it doesn't, now that time your that particular data node goes down. Now it will have that multiple task attempts are there. So every attempt will
Hmm.
give a task attempt ID. Now here
Hmm.
it will list that one. So what is the attempt ID and the status and how it is unable to connect to. So will be listed here. Once the job is finished and the job output is given to the client, then everything is going to be deleted. Otherwise, it will show the task, right? How many attempts? Attempt one, attempt two, and each attempt its status and how much it is it's completed, and what is the each error, what is the each attempt, what is the error it will get is going to be listed here.
Okay, suppose if I have an, I mean, suppose if I found some issue, I mean, task items, there is some problem in that. So generally, do we need to do manually, or again we need to restart this job tracker, and then automatically it will go? How it will be? Because
Right.
generally in my situation, suppose if any issue comes, we need to do the manual troubleshooting. So then only it will go that.
Yes,
So
Venkat.
that's why I mean,
Venkat,
yeah.
two things again. The job, if you are unable to complete the job because the code error, if you are unable to process the
Hmm.
data properly, is one error. We have to
Hmm.
troubleshoot. Otherwise, the data node goes down where the data is available. Right, the data
Hmm.
is not available. The two things of errors generally we can get. Right, one is the code or the
Hmm.
program or the job which we have written is not in a
Yes.
correct way, is one reason where the job is cannot be a successful. Correct. And the
Hmm.
second one is if
Yes.
we are unable to retrieve the data from the data node because that particular data node is not available. Two
Yes.
reasons we have. Now, first one, you can trace it where the error is. You can use gedit, right? You have the different environments are there, so manually we can able to see that. Now, when is the
Right.
data node goes down, now if here it will show that it's not available. We can't do anything from the task tracker page, right? So the reason
Yes.
for the log, go through the log page, check the information about that particular job, reason for the job, then manually how to come with the. So if what is the issue here, SDFS, what are the files which are available, what is the files which are available, the reason. If your data node goes down, then we'll come and we'll see the state health of the cluster here, right?
Mm-hmm.
Which data node goes down will be listed here, right? In the SDFS. Where is SDFS? Right, somewhere right now here we can see the data nodes, right? So what are the data
So,
nodes are there and the reason for the failure of the data nodes, right? So we have to do it from here, because if the data node goes
okay.
down, it's a different issue. If your job error
Mm.
is there, it will be the different issue, right? So there are the
Yes.
both the situations.
Okay. So each and everything we need to monitor and troubleshoot it,
Yes,
and
you
then
need to
resolve the issue.
monitor. Yes, this Cloudera manager is there. Its responsibility is to monitor all the activities.
Okay. Okay.
Right, so that's no, it's a Cloudera. It's they are using Cloudera manager. So until and unless you are using Hadoop from the Cloudera and Hadoop from the Hadoop from the Artenworks, it we don't make much difficulties with the environment. But so if you are
Mm.
having with the mapper, so you all those things are very difficult things there, because they have really done the Linux.
Mm.
So we don't have
Mm.
this kind
Okay.
of GUI, this kind of environment there.
Okay.
It's a simple things we can able to do here, right? So
Just give me 1 minute. I'll come. Huh?
okay. Okay, suppose if one job is not working well, if it is goes down, now you can able to see this one. So the activities of the map reduce one, so the jobs which have executed will be listed here. So now we can able to see the status, why the job goes down, why task attempt is unable to retrieve it. So everything is going to be listed here. If you click all activities, so now we have an activity monitor server is available. So this will monitor these jobs. Okay, so like this we'll configure. Santosh,
అజయ్ అది నార్మల్గా క్లస్టర్ సెటప్ మామూలుగా ఇప్పుడు క్లస్టర్ ల్యాబ్లలో సెటప్లు అవన్నీ హడూప్ అడ్మినిస్ట్రేటర్ చేస్తారా సిస్టమ్ అడ్మిన్ చేస్తారా
sysadmin both should sit together, because this configuring SSH generally goes to the network admin, right? So the Hadoop admin will responsible of providing the Hadoop configurations. All those things are done by the Hadoop admin. So generally, if it is a Hadoop administrator to configure the multi-node cluster, now so the connectivity between the systems, the nodes are taken care by the sysad network admin, right?
ఓకే
Then after that, the configuring the Hadoop to make the Hadoop available to connect to the all the nodes, accessing SDFS between the nodes can comes as part of the admin role.
ఓకే అంటే నేను అన్నది ఏంటంటే ఫిజికల్ వర్క్ ఉంటుందా మాన్యువల్ వర్కే ఉంటుందా
I didn't get you in the sense of physical and manual work.
ఓకే నార్మల్గా ఫిజికల్ వర్క్ ఏమైనా ఉంటుందా నార్మల్గా
No, we won't do that. Physical work, we won't do that. That can
ఓకే
be done by the sysadmin and network admin. See, the most highest paid job with a topest priority job is right now is the Hadoop admin. The most hard, difficult job with a high paid salary is only the Hadoop admin. We won't do with the small kind of things. Everything is getting ready. A configured nodes are available. Then your job role comes here. You spend some time to configure Hadoop. That's it. So the that we won't do thing. Actually, we won't do that one.
ఓకే
Santosh?
Yes.
Yes, Santosh. Yeah. Any questions here? You're clear with this?
Yeah, I'm clear with this.
Okay, now
And Ajay Venkat here. So the admin role is very difficult, or how it will be? Suppose the person should know the administration background, so then only he can able to manage all these kind of
uh,
situations.
no, not exactly like that, Venkat. See, generally because we
Mm,
are already working from years, right? So we know the environment. So we know
mm,
the thing is how to work on that one, right? The thing is it
mm,
should know the
mm,
terminology. It should know the basic working environment. So then after
mm,
that, what we have to do now? So just they will help you most of the times. Every thing you will get the support from this one. Suppose I don't know what to do, if you type sdfs, now they are showing here what to do with sdfs admin, right? So these are all the tools where admin has to work. Only these are available.
mm.
Apart from that you won't do anything. Now you want to format,
Oh,
you want to run, name node is stopped. You have to start the name node. How you start the name node? Then I'll write sdfs space name node, then I start. Now name node is started, right? They are
mm,
giving this kind of help. So that is working with that. It's a fine, we can able to work here, no issue, right? Easily we can able to work. The thing is what you should know, the basic things, how to do that, where the file is available. So
okay,
the
okay.
first and
So
top, yes, the
the
first,
basic information should know. Mm.
yes, the first
Please,
thing,
please.
yeah, first thing and the top priority thing for everybody, first you should know the environment. We should know the location of the
Mm,
files. You should know the how to do
mm,
that, because even it's
mm,
no need that you need to remember all the exact syntaxes, everything. No need to remember, but you should know, right? So this command is available with this one. So if you're able to run this, we can able to do this one. You should know that concept. You should know the concept how to do that, right? So now if you know this, we can able to that. That only the thing is you should able to work with the environment. You're much flexible in working with environment. So if you're searching for the files, you're in a searching for the
mm,
files, you can't able to do anything, correct? You should know
mm,
the
mm.
files and the locations where you find that option. That you should know that. That's
Oh,
it. The basic thing, as
okay.
per my experience, everybody should know this one. So how it is available now? I want to check the way. What about how to configure it admin? Then where do you find? If I know that it's available with sdfs, we can able to see that. The thing is it should be good in working environment. So that is
Mm,
the one thing, the minimum, right? We should know to work with the Hadoop.
okay.
Okay. So now, right? So this is a name node, and right, we can see the job tracker like secondary name node. So if it is a name node, then after that we have a secondary name node.
Mm,
What is a secondary name node, right? Just I'll define that secondary name node. We'll see the complete thing later. The snap, generally the people are thinking that secondary name node is the backup node of the primary name node. It is not a backup node, right? And we are not taking the backup of the data, because your data is available in data nodes. Your data is a bulk amount of data, right? So we don't simply will take the backup of the data, because already we are storing that data as a multiple blocks are going to be distributed, right? The same blocks are available into the three nodes. So we give less priority to take the backup of your data. If you think that your data is critical and it's important in it, then only your client prefers to take the backup of the data. But most of the times when you're writing the data onto the cluster, means your data is going to be replicated. After that it is going to be distributed. So we'll give a less preference to the backing up the data, actual data. Fine. So now comes to the name node, right? I told name node is a second single point of failure. That is, if your name node goes down, we cannot able to continue the cluster. That is, if name node is down, means the entire cluster is down. Okay. So now what we have to do is, now snapshot. Just try to remember this as it is. Snapshot of primary name node. right? Snapshot of primary name node is written to secondary name nodes. The best and simple definition for the secondary name node is snapshot of the primary name node is written to the secondary name node. See, generally we have a checkpoint time is there. You know what is a checkpoint? It is admin role,
Yes.
right? What is a checkpoint? Suppose when you are working with Aracle, so if it is checkpoint means it is committed, that so that it is going to be updated, right? So see here, I'll give an example. Suppose checkpoint occurs means the data will be written into the name node as well as secondary name node. Suppose the last checkpoint occurs at 10:30 a.m. means, so all the user data is updated into the name node as well as secondary name node. Okay, checkpoint occurs. Now whenever the checkpoint occurs in the next checkpoint time, the snapshot of the primary name node, so whatever the files are the data which you are going to write into the name node will be written into the secondary name node, right? So 10:30 you wrote some data. Now so whatever the data they are writing is written in the temporary into the name node is available. Now again next checkpoint time is 10:45. Now whenever the checkpoint occurs, now the data which you are going for this name node is going to be updated into the secondary name node, right? So what the complete snapshot, right, is of the name node is going to be updated in a secondary name node, so that if your name node goes down, then we'll get this snapshot from the secondary name node and we'll make the name node up and run. So this is the reason we use a secondary name node. I'll repeat. So when we are going to write the data, it will be written into the name node, right? The reference is written into the name node. So whenever the checkpoint occurs, that is whenever the checkpoint time occurs, then whatever it writes this time in the name node will be written into the secondary name node. That is taking the snapshot. That is now whatever the data written by you till 10:30 p.m. is available in a name node as well as it is available in a secondary name node. Then what is the next checkpoint time? 10:45. Now, so whatever the data you are writing between 10:30 to 10:45 is updated in a name node, but it's not written into the secondary name node. Correct? See, now if your data node goes down at 10:40, now can we able to retrieve this data? The data which is
No.
written between 10:30 to 10:40, because you don't have the backup in secondary name node. When you will have the backup in secondary name node, when checkpoint
After
occurs,
we.
but what is your checkpoint time? 10:45. So means every 15 minutes the snapshot of the primary name node is going to be updated into the secondary name node. But if something's happened in before that 15 minutes, right, that's after 10 minutes, your this particular node goes down. Means whatever you wrote between 10:30 to 10:40, have you retrieved the data? Correct. So that
Yeah.
will take another node. That node is called as a HA node.
Okay, Ajay, one question here.
Yes.
Is there any automatic update? But generally, when we write in a documentation, so automatically the text will be updated like that. So, is there any way, kind of, or only we need to wait for until we have finished the uh, job and then we have to update? Then only it will be
No, no,
stored in the secondary.
we won't do anything. That can be done by automatically. Suppose if you open this 50090 secondary name
Hmm.
node web UI, correct?
Hmm.
50090. See here you can able to see, right? Last checkpoint time. Okay, so when every 3600 seconds checkpoint is going to be occurred, means every
Hmm.
3600 seconds means every 60
Okay.
minutes,
Hmm.
right? Immediately the
Hmm.
snapshot of the primary name node is written into the secondary name node. We are not going to do anything by default. It is going to be updated, right? So that
Okay.
means then
Okay.
it will be written into this location.
Hmm.
అజయ్ ఎంత డేటా ఉన్నా అని అది 1 hour అయినా మనం ఇంకా పెంచుకోవచ్చు అలా.
ఇంత డేటా అనేది ఇక్కడ మీరు ఇట్స్ ఓన్లీ ద నేమ్ నోడ్, ఇట్స్ నాట్ అబౌట్ ది డేటా నోడ్స్.
నేను అనేది ఏంటంటే
Name
ఈ
node, how
చెక్
much
పాయింట్స్ ఇది
data?
ఎవ్రీ
See,
1 hour.
Name nodes data is
Okay.
limited. We don't have the bulk amount of data. Max name node will have how much? It's a text data. Name node contains only
Yeah.
name of the file,
Limited.
size of the file. That's it. So if it is how much big you can able to create, how much text will create, right? Even if you are working with the multi terabytes, it doesn't go more than 1 GB. Got it?
Okay.
And moreover, Nageshwar, it's very important.
Yeah.
Santosh, name node stores its data into the RAM, not in a disk.
Mm-hmm.
Okay, name nodes
Okay.
metadata. So whatever you are writing between this 1030 to 1040, so this is available in primary memory. That's RAM, name nodes RAM. So that if your name node goes down, this data is going to be lost. Otherwise, if you are writing the data into the name node secondary memory, if it is goes down, what happens? If you start up the disk again, we can able to retrieve the data. Correct. But
Yes. Yes.
the thing is, in the name node, it writes the data into its primary memory.
Mm-hmm.
So
Okay.
that because if it is in a primary memory, then only we can access able to access fast.
Yes.
Correct. That is that is the thing here. So if you're so in the primary memory, general how much RAM? We don't have the RAMs of 1 TB. Correct. Right.
Mm.
So we'll configure 1 GB RAM or sometimes 30. Like it's based upon we'll configure. So we'll have a
Okay. First of
calculation.
all, we should know that prerequisite. Like I mean, so we know how much data we have. Based on that, we need to install all these RAM, I mean, nodes.
We have a
Or
no, we have the calculation for the name node memory. We can't give you
okay.
exactly 1 GB. So we have a mathematical calculation. We have to do that. I'll tell you in the
Okay.
coming sem because as of now it difficult for you to right. So it's we have to number of six is going to perform all these things based on that one you have to write that we have to it's a mathematical calculation we have to identify the because it's a role of admin. You have to plan the cluster. Raju, the one
Mm-hmm.
of the responsibility of a Hadoop admin is to plan the cluster. So because it
Okay.
will be given very much seniors, right? So how much RAM we require, how much name node memory have to specify. It's a calculation, so you have to go for little bit mathematical calculations you need to perform here.
Suppose if do we when any mistake comes in the calculation, is there any problem or how? For example, there are 128 GB of the space. Okay, it's required, but 125 we have given. So in that case, is there any problem?
Yes,
I mean,
because we are unable to accommodate. Correct. Where
acha.
it will throw the error. Right
Mm-hmm.
means
Okay,
you have to go
because
for yes, it will throw
the
the
data will be stored in a blocks, right? So I think if it's more than, I mean, 4 KB or 5 KB, so I think only it will occupy the complete data, and some of the data, I mean, some of the storage will be empty. So in that case, really problem. Like I mean,
no no
I'm little doubt on this.
no, no, actually the question is wrong, Nageshwar. Here we are
Oh,
talking about the name node. It's a primary memory, and you're giving an example of a data nodes very secondary memory. Writing it into
mm,
secondary memory is different because in
oh,
see one drawback in Hadoop cluster, one Hadoop, right?
mm,
One drawback, one negative. Like the cons, we can say the cons in Hadoop is we are not utilizing the complete disk space. We are using only one fourth of the disk, right? Because we have configured 1 TB, then we are going to use only 1 by 25th of the storage. So now these are all things are we are not using this because you're going to write a file of 1 TB, right? So there are the 10 data nodes are there. How many data
mm,
nodes? 10 data nodes are there. Correct? Now, what is
mm,
the file size? 1 TB. Means 1 TB divided by 10 means we are
10.
only writing 100 GB in this data node. And then what about remaining storage in the disk?
Yes,
Yeah, that's one. We can say
honestly,
it's one of the con in the right. So it's in the data node, right? It comes into the
so
data node. Now it's not.
in this case, yeah.
Yes,
Yeah,
Nageshwar.
in this case, I mean, the clients will not agree on this. I mean, will they come in because because they are investing a lot of money, right? So in this case, I think any client will come up
Yes,
and
they'll raise the issue. Why won't raise? Because it's because it's a bulk amount of data and you're using only one by fourth of the data. So we have an option here again. We can use some data as for the non-SDFS because in the data nodes we have SDFS available. So now in this one, 25 percentage we have used for the Hadoop and we can configure
Hmm.
remaining 70 percentage for the non-SDFS.
Okay, for example, if we allocate that non-STFS for 75%, in future, suppose if any data comes up, if we want to allocate that, so we can do that, right? So the non and assigned to that I mean STFS. Is there any?
Come again, suppose.
No, no, actually, so this is in 100% data. So, 25% of the data we have allocated to the non-SDFS, and 75% of the data we have already allocated to the HDFS because it is occupied, full occupied. For in future, suppose, and the HDFS is full. Suppose if it requires for 10% of the data, so that 10% of data we can accommodate from non-HDFS to HDFS.
No, I, actually the thing is, yeah, again you're confusing here. See, when you are going to write the data, we never writes complete data into one node.
Mhm.
First comes to the definition. Hadoop is a distributed data processing system.
Yeah,
That is,
distributed.
your data is going to be distributed. Means we never writes complete data into the one disk.
Hmm.
Right, how much the storage you're having, but always your data is distributed, means it will be divided and it will be distributed, means three blocks are going to be created, one block of each node and another block of another node is written into this disk,
Yes, yes.
means
Yeah,
we are
understood.
using
But
only
yeah,
that one, we are
my,
using only
yeah,
that one. Let me complete.
correct.
We are using only
Hmm.
that one, and how much we have, again whenever you are going to write some again another file, right, what it
Hmm.
will do now it will check how much
To create
storage we
one.
are having now, because we always will have, we when your business running going good means you are having more number of clients. In that case,
Hmm.
we always add one node to the cluster. We will keep adding a new node to the cluster. This it's a general principle in Hadoop is every 1 month, based upon how your the data is growing on that one, based upon your client's historical data policy, we always keep adding a node to the cluster. So generally, if you say right now we are having a 5 data nodes, so after some days it goes up to the 6 data nodes. We never always
Hmm.
will have same size of the cluster.
Yes.
Now
Hmm.
if more data is there, now we won't use this SDFS and we'll add one more node to the cluster,
Hmm.
right? But we don't try to adjust the data into the one data node because
Yeah,
it,
that's what. Yeah.
yeah, it checks, suppose see here how much data is available and how many blocks are it is going to write. So the number of blocks
Hmm.
can you able to accommodate in all the disks or not. The first thing is, because we have to
Hmm.
balance the cluster, again there should be how to run the balance cluster to make the data equal size in all the data nodes.
Understood.
Okay, so
Yeah,
that's
everything will
different.
be calculated. Yeah. Okay.
Yes, everything is calculated, and we are at the end of the day, some we cannot able to utilize the complete storage space in Hadoop, right? Always we cannot use that one because it's our thing is what our main focus is the fast data processing. So here it go. This is to be you need to bear this one, and see then if you say it's like that, some people needs, some clients prefer to take the backup of the data. Then how many disks they need to use?
Oh, okay. Hmm.
Okay,
But in
so
that
See,
case, I think.
so generally Yahoo is running 1000 node cluster, 1000 nodes they're having. And Nageshwar and Raju, Santosh, I told in the initial session, when we are working as a developer, we are nowhere related to the number of data nodes in a cluster. Right? We are nowhere related to the size of the cluster. The complete abstraction is provided to the developer side. So that is the advantage of the Hadoop and that is the advantage of the MapReduce. right? So you should only give the reference to the name node. That's it. So we'll connect to the name node. So let it be any number of data nodes. So we never specify in our job to run this data in this particular run this job in this particular data node. We don't specify that one. We just target the name. We just assign this job to the name node. Now everything number of nodes, how to process everything calculated in internally and will be processed. Okay,
Yeah.
fine. So any other question, Santosh?
As of now, you said the data is being distributed to all different nodes, right?
Yes.
So when the data is distributed to all the different nodes, can we change the size of the node dynamically,
No,
if at all,
no,
in future?
no. We
So
won't change
the size
dynamically.
of the node is fixed.
Yes. That means it's a 1 TB disk. So now if it is a 100 node cluster, all the 100 data nodes will have 1 TB disk in all the 100 nodes. So that is the size of the cluster node of the disk in the node, right? So now it will be equally distributed the data which is going to provide into the all the data nodes. Now you need more data, you have to add one more node. That's it. You have to add one more extra disk to the cluster, right? But
Okay.
it's a little bit difficult thing for the beginners. So if it is a complexity arises here, please as of now you can skip this topic. Okay, just try to know. If you are unable to understand, even though it's okay, no issue, right? Anyway, we'll have all these things. I will have discussions in chapter 3 because before that I need to explain what is fs image file, what is edit log file, right? So that's once if you know that one, what we have the name node and how the writes are written into the name node, how writes are written into the data nodes, where these returns are there, can we able to see the blocks. If you know those things, then we can plan for these things. Okay,
Okay.
so it's a beginner level because even right now as of now we all can skip this one. It's not that much of important. Okay, so because in the Hadoop, one again, the most complex thing is to understand its architecture. It differs. It with HA is one thing and without high availability is one thing. If you configure with the second name node is different. If you don't have the second name node, it is a different. Okay, so now, so these are the Hadoop domains which are running in the cluster. Now, see, we can administer with the Cloud Data Manager, or we can use Hue, right? So where we can we can work with a SDFS. Now here it's a developer site. So these are all the Hadoop, Hive, Impala, Pig, HBase, right? So where we can able to write. Suppose if it is HBase, simply we'll click on HBase, right? We'll start working with the HBase, right? It's completely GI mode, right? Right, see now it is what is saying that could not connect to localhost 9090 because HBase is not started in the cluster. So what if you have to do? Now check the issue, what happened with the HBase, why it is not running. See, right, it's saying that HBase is stopped. So now in the previous run, when I try to work with the HBase, what is the error here? Could not connect to localhost 9090 because
Oh,
see here why troubleshooting comes to the HBase because HBase is stopped, right? Running HBase is running region server, master server, HBase thrift server. Now we have to start this one in order to use HBase. Come here and click on actions. Now HBase one, right? Start here, right? Are you sure you want to run start command on the service HBase one? Click start. Now it will try to start the HBase. Okay, now once HBase is started, we can able to work with the HBase. So like this we have to do.
HBase is purely on admin component, right?
No, no, HBase is a database. It's a NoSQL database. We will have DDL DML commands we'll work with. So the configuring the HBase is an admin part,
Mhm.
right? Basically, what I'm having, my data is available in HBase. Now I need to process the data. then generally see we have the data in Oracle. Now I am writing Java program, so we'll connect to the database. Then how generally what will be our role? Our role is performing basic DDL DML operations from the Java. We'll write a Java program in the Java. How much data we are required, we'll connect and we'll get it. But if you want to
Mm,
write a PLSQL program, then it will be given to the PLSQL developer. We won't write that one, right? Right?
mm,
The
mm,
part if it is a programming only for the Oracle, it will be immediately sent to PLSQL. Why don't write it? Because I'm a Java. The same thing now. If it is a H-based program, you have to write. Then we'll give it to the H-based developer. It's not comes as a Hadoop developer again. So, but as a Hadoop developer, what we should know how to retrieve the data.
we,
DDL like
we
so.
just
Yeah, here it's a CRUD operation. What we call CRUD. CRUD means create, read, update, delete. This we should know as a Hadoop developer. That's it. How to create the tables, how to read the data, how to update and how to delete. So that this we should know. So again, if you want to put little bit programmatically, then you should be a H-based developer. Okay, right? So it's a secondary name node. We can see like the information. Now 500360 is a task tracker, 7075306090808020 and 8088, and Hue is available in 8888. Okay, so now how to work with Hadoop? It's simple. See, suppose whatever you type Hadoop space fs. Now, so these are the commands available with Hadoop. So now if you know how to work with these commands, then we can able to work the Hadoop. Right? So these are all the commands which are available with the Hadoop environment. So only these commands are available. So there is no other commands other than this. Okay. So to administer the SDFS, only these commands are available. Right? Suppose if you want to make HA admin SDFS space, if you write HA admin, press enter. Now what you will get? So these are the things which are available with HDFS. Okay. So I'm going to teach you all these commands in chapter 3. And all the commands with Hadoop FS in tomorrow session. Okay, fine.